In this section, we're going to take a look and discuss unmanned aircraft systems. So what is a system? Well, the dictionary defines a system as a regular interacting or independent group of items forming a unified whole. So you can call them either independent groups, I call them elements. We're going to take a look at all these elements that actually make up an unmanned aircraft system or UAS. So, and later on in the course, we're going to take a look in depth of each one of these independently. So we'll get just a brief overview in this presentation. So the first one I want to discuss is actually unmanned aircraft. So unmanned aircraft can be a variety of aircraft, as we already seen. They can be balloons, they can be lighter than air devices, they can be multi-rotors, they can be vertical takeoff and landing aircraft, they can be fixed wing, they can be a variety of different aircraft. Now the FAA defines an unmanned aircraft or UA as an aircraft operated without the possibility of direct human intervention from within or on the aircraft. So basically it's unmanned. Now later on when we get into some of the other definitions, we'll find out that they also include model aircraft or hobbyist aircraft as an unmanned aircraft. And when we use the term aircraft, there is no difference between talking about an unmanned aircraft, which could be a DJI Phantom or something like a Scan Eagle or a Hunter, on the same perspective as a Boeing 737 or an Airbus A320 aircraft. So they all consider that these are aircraft. So that is the first part. In order to have an unmanned aircraft system, you have to have an unmanned aircraft. So the next thing is once we have an aircraft, we have to have the ability to launch and recover it. So depending on the aircraft, it may be a hand launch like some of the small aircraft, the EPO foam that you can buy in a hobby shop or off of Amazon that you can launch and it will do a belly landing, to where we saw like on the Kettering aerial torpedo was they actually needed a rail system to launch it, and even the V1s, the German V1s, needed to have a launcher system for it. So one thing to keep in mind as the aircraft go up in weight, then you usually have to have some type of launching system for it if you can't launch it by hand. And sometimes, even though an aircraft may be light, you may want some type of launcher just for safety, or always to have the right angle and airspeed for that aircraft to come off of a launcher. So those are some of the things to be thinking of when you do this. Same for recovery. So like I said, if you have just a hobbyist aircraft that's pretty light, EPO foam, is it can do a belly landing without much damage. Once you start getting more mass, more weight to it, it may be too dangerous for it to come in and land on the ground. The other thing is it may do too much damage, or you may have sensor systems that are on the belly of the aircraft that you need to protect. So you will look at different recovery systems, which could be like in the Scan Eagle's case, comes in and snags a rope that's suspended from a tower. Other aircraft will land like conventional aircraft and use a runway. Some may use nets, some may use parachutes. So we'll kind of look at the benefits and the downsides to all of those. Now once we have a unmanned aircraft and we have a way to launch and recover it, we have to have some way of communicating with it. So the communication data link. So we need to be able to send commands to the aircraft, and depending on what the payload is, we may need to get some of that data back. So you've seen all the videos on the Predators, so they are sending signals to the aircraft and they are getting imagery back from that aircraft. Now some aircraft aren't that sophisticated. You may be able to, well, for good examples, an RC airplane is I'm communicating with it and I'm sending the signal to the receiver, which is sending it to the servos, which I'm controlling it, and in reality I'm not getting any data back from a data link, but what I am getting data back is from me actually seeing the aircraft. So when I command it to go up or down or left or right, I'm actually getting a visual input of what that aircraft is doing. So later on, some of the aircraft that we're building in the program, we actually use telemetry modules that will give us headings and altitudes and airspeeds along with some of the other system functions of the aircraft. Same thing if you're using an aircraft for surveillance, and you're going to hear the term ISR, which stands for intelligence, surveillance, and reconnaissance. Once you send the aircraft out, you need to get that information back to the operator. And the same thing is once we're communicating and need a data link, then the next thing that we're going to need is some type of command and control system for this. So a lot of times you may hear this referred to as C2 or C squared, but you have to have some way to command it. So even a toy airplane, when I'm down there flying, regardless of how I'm communicating, I am actually in command and in control of that. Same thing as if we use some sophisticated autopilot system, then we may have to program that. So we may have to program it ahead of time to actually do the mission that we want. We put in the flight plan and other parameters, but we have to have some way of talking to it, and we have to have some way of commanding and controlling the aircraft. Otherwise, it just becomes a drone. So the DQ-21s that we saw earlier that were launched off the backs of the SR-71 or actually from under wing of the B-52s, those were pre-programmed. So the command and control of those was actually prior to the mission. Once they launched, they flew a pre-programmed route. They came back, deployed a parachute, and they were recovered. So the next element we want to look at is a payload. This is probably one thing that a lot of people overlook. The only purpose of an unmanned aircraft is to get the payload to the area that you want to gather data from. Okay, that may sound a little backwards to people, but people think the aircraft is most important. No, it's actually the payload. So regardless if it's a multispectral camera that's going out to survey crops, or if it's a single camera to do out intelligence, surveillance and reconnaissance, or if it's a thermal infrared that's doing the roof inspection, that is the only purpose of the unmanned aircraft. So you have to have a payload system. Later on we'll talk about dispensable payloads. So for example, well, the good example is if Amazon Prime Air gets their way, you'll be able to sit at home, order your chapstick, press a button for delivery, and the drone will be delivered at one of the Amazon delivery centers, and it will basically fly to your house and land somewhere or drop a package on your front yard. That will be a dispensable payload. Other payloads are not dispensable. For example, if we're flying a LiDAR, which is a sensor that uses light measurements, all that. Some of these can be upwards of $100,000 or more. The last thing you want to do is be dropping that out. So we'll take a look at different payloads that aircraft can use. Now, another one that everybody usually forgets about is logistics. So, the military runs on beans, bullets, and band-aids. But if you're going to work in remote locations, so let's say that we were going to do an operation, we're going to do a mission out in Center Hill Lake. You need to make sure that you have enough supplies, not only for the aircraft, but for you yourself and the team that's out there. So you need spare parts, spare batteries, connectors, consumables, expendables, all that. So that's some things that we're going to take a look at, or some of the things to consider. What do you need to take with you? So there's nothing more frustrating than going on a camping trip, getting all the way up there and, you forgot to bring something. So logistics is a huge part. When you start talking about the military, we'll kind of look at that versus civilian operations. If you look the military for a system such as the Predator, the Hunter, or the Shadow, even the Scan Eagle, is you have a team of people there. It takes people to maintain the aircraft, it takes people to maintain the engine, the avionics. You need fuelers, you need people to work on type of battle damage to repair wings and all that. So once you have this group of people, you got to figure out a way to feed them. They need medical needs, and of course the military runs on paperwork. You can kind of see how this starts to escalate, as opposed to a little 1 or 2 person operation where you're responsible for yourself. So logistics is a big part of it, and it's often overlooked. And the last thing we're going to talk about here is the human element. So it's kind of interesting. We talk about unmanned aircraft systems. So why are we talking about the human element? Well, it takes a human being to either program this, pre-program it, or to command and control it. But even though we used to talk about, when I was flying Scan Eagle, even though that we were physically removed from the aircraft, you were still emotionally attached. So I've heard stories of people in combat taking fire, ground fire from hostiles, and actually ducking, even though they were flying the aircraft from, hundreds of kilometers away. But there's always going to be the human element. So even though we talk about being unmanned, so you're not physically in the aircraft, but you are physically attached to it through communications and data link, all that. So we're going to get into the human element and look at safety and human factors later on when we start talking about regulations, part 107, which is the small unmanned aircraft systems regulations that allow us to fly in the National Airspace System, you'll see that it is filled with the words safety, crew resource management, human factors. It's huge. So a lot of the accidents that have been attributed to unmanned aircraft is actually goes back into the human element, the human factors, errors made by operators, designers. So we'll take a look at that. So looking at all these elements together, that makes up an unmanned aircraft system. And like I said, in the coming weeks, we're going to look at each one of these a little bit more in depth, but that's what makes up an unmanned aircraft system.